start taking space by storm. Today we're talking about NASA's CAPSTONE mission to the moon. It's been quite a roller coaster ride so far for this microwave oven-sized satellite, so let's find out more about it. CAPSTONE, short for Cislunar Autonomous Positioning, System Technology, Operations, and Navigation Experiment, is one of the first projects associated with the upcoming NASA Artemis program. It's a 55-pound CubeSat primarily designed to test out the feasibility of the unique near-rectilinear halo orbit that will be used by the Orion capsule and the Lunar Starship when bringing the astronauts back to the moon. CAPSTONE will also be testing out innovative navigation technologies associated with Artemis, as well as working in tandem with the already orbiting Lunar Reconnaissance Orbiter, proving the logistics of future spacecraft and allowing them to navigate near the moon without as much tracking and guidance from Earth. CAPSTONE also brings a new partner into the moon program, Rocket Lab. Rocket Lab launched CAPSTONE on June 28th from their Launch Complex 1 in New Zealand using their Electron rocket. Electron delivered CAPSTONE to orbit along with Rocket Lab's new Lunar Photon upper stage. Lunar Photon is Rocket Lab's novel hardware system integrating launch and satellite solutions into one platform. Serving a role as both payload adapter and kickstage, Photon eliminates the need for dedicated adapter hardware that will ultimately be tossed away to burn up. Photon is designed to be used to boost all manner of payloads to LEO, MEO, GEO, and beyond, including lunar and planetary destinations. In fact, Peter Beck, Rocket Lab's founder and CEO, has previously advised the public that Photon will be used to send missions to Venus, a science destination he's been advocating about for years. Photon showed off its kickstage capability on July 4th by completing a trans-lunar injection burn and successfully deploying CAPSTONE on its 4-month journey to the moon. However, once CAPSTONE was on its way, an issue quickly cropped up. Shortly after CAPSTONE separated from Lunar Photon, NASA lost communications with the CubeSat. At that point, no one knew what the issue was or the health and status of CAPSTONE. For 2 days after the U.S. holiday weekend, the public waited with bated breath for any information. Fortunately, good news was delivered on July 6th that NASA had been able to re-establish communication with CAPSTONE. All signs indicate that the satellite survived its blackout unscathed, and its health and telemetry remain good. NASA advised the issue was caused by an improperly formatted command issued by the spacecraft operations team when they attempted to access diagnostic data on the spacecraft's radio. This command made the radio inoperable. Normally, the spacecraft's onboard fault detection system would have rebooted the radio, but an unknown error in the flight software prevented such a reboot. However, CAPSTONE's autonomous flight software eventually was able to clear the error and brought the radio back online, allowing two-way communications once more. Signifying that all was again well with CAPSTONE, the satellite completed its first engine burn on July 7th, a burn that had originally been scheduled for July 5th. Its velocity was changed as planned, and the CubeSat is well on its way to the moon. A series of trajectory correction burns are scheduled in the future to better refine CAPSTONE's course. CAPSTONE will spend at least 6 months in orbit around the moon as it carries out its mission objectives. That's all for this video, friends. See you next time, and remember, take space by storm.